All right, so we're on to energy. This is the last unit we had, and this year, anyways. So what is energy? It's the ability to do work. Why is it important? Because you do it in everything. The ability for you to wake up, the ability for you to eat food, to play those video games. You need energy. It exists in many forms: thermal, kinetic, electric. Electric, you charge your phone. Thermal, staying warm. Kinetic, movement. Energy is never destroyed, but it can be moved from one place to another. We call this the law of conservation of energy. This is called an energy transfer. A soccer player kicks a ball. The ball's energy went from the leg to the ball. It's then moving across grass or floor, and it's giving the energy there until, because it's creating friction, until it stops. What is our original source of all energy? Yeah, you should have said the sun. Okay. This energy must be transferred or transformed in order to power living systems. Everything we have comes from the sun. The light in your house to the food that you eat, it's all coming from the sun. Energy is used, moved, and transformed, but never destroyed. We lose it as heat to the atmosphere. Remember, your body wants to be in equilibrium with the air around it. So your body's around 98 degrees. They used to say 98.6, and the air around you is 80 degrees. Well, it's constantly giving off, your body's giving off heat because it wants to be the same temperature. You're running around, you start sweating, you have now become hotter than the air around you. So now the air is giving your body heat, which is why you feel warm. Transformation, and you guys can put this down here in the little note section, okay, is one form of energy is converted to another form. An example: chemical energy stored in a battery is transformed to mechanical energy in a remote control toy car. You have batteries in your remote to turn on your TV. They're stored energy until you press that button and it's become mechanical energy. Types of energy transfer. So the first is thermal. It's a transfer of energy through moving particles. Your hands, and you rub them together and you go like this and they get really, really warm. That is thermal energy. The molecules that are on your hands are moving and they're creating a friction, which you feel as heat. Two methods of heat transfer. There is conduction and convection. Remember, conduction has the D-U-C-T in it. That stands for duct tape. And remember, I can't stick a piece of duct tape to the air. It needs to touch something. So through direct contact. It usually travels through solids. If you touch a hot stove burner, the heat is transferred to your hand by conduction. You've touched it. Convection is the circulation of energy through liquids or gas. The circulation of heat and fluids. Fluids are classified as both liquids and gases. Okay, so it's a liquid and gas. Fluids, usually just think water, but it's both. Warm water rises above cool water. So you have your picture. The warm water here is going to rise. The cold's going to sink. Then it's going to get warm, but it has to get warmer than the warm water. So now you have warm water with warm water. Then you get warm water to rise above the warm water. And then you have to get warm water to rise above the warm water. You get my picture? It sounds super. Yeah. Okay. Until you get boiling water. Second is mechanical. Mechanical is movement of energy from one moving object to another. A moving bat hits a baseball. It's one thing in motion causes something else to go in motion. Rube Goldberg, all those little videos. One thing hit the other thing, hit the next thing to create movement. It's a push or a pull over distances. So it can be, you pull something and it causes a chain reaction. The third is electric. Is an electrical source. A battery or a generator completes the circuit. A circuit has to be complete. The circuits are closed so the currents can be conducted. Batteries are used to provide stored energy. Closed circuit allows transfer of electrical currents and they power many devices. If you put batteries in wrong, it doesn't work. Why? Because you did not complete the circuit. Lights. If you shut the lights off, then you have broken the circuit. When you turn it on, you complete the circuit, and that's why the lights come on. Different type of electric. Electromagnetic waves, its energy travels in the form of waves. You have visible light, UV rays, infrared, radio, gamma, X-ray, etc. Remember, the wave is a disturbance in matter. It's sending out energy. You have transmissional light. This occurs as light passes through something. Eyeglasses transmit more light than sunglasses. How easy does light go? Does light go through it? So glasses, there's no shading, there's nothing on it. Light goes right through my glasses very easily. If I put on sunglasses, it's blocking the light, so it doesn't transmit. It doesn't go through as easily. You can notice that in the picture down here. Refraction of light occurs when a light is bent as it enters a substance and changes paths. You have white light. It comes in, it bends slightly, and notice it bends as it comes back out because you've gone from a gas to a solid, from a solid back to a gas. You're changing, it's speeding up, okay, as it leaves. It's slowing down as it enters. Light travels fastest through empty space. Reflection of light is, it is not taken in, so we don't absorb it, and it can be scattered as in the blue sky. So a reflection can be it doesn't bounce back, or it can bounce back because it's not absorbed, or it can be taken in completely and you don't see anything. There's a picture of the electromagnetic spectrum. Notice that the radio waves are straight all the way to the gamma rays being super tight and close together. Visible light is right in the middle, but the visible light is a small part of the spectrum. Infrared to UV, increase energy going to the right, increase wavelength going to the left. Those are important. You have the picture in your book as well that shows they're 10 to the third is radio waves, so 10 times 10 times 10, where gamma rays are 10 to the negative 13th. That's how small they are close together. And we'll pick that up next. Have a wonderful one.